Hello dear children, welcome you all back to science class. In today's class, we are going to begin with the new chapter, that is chapter 11, work and energy. So first, let us see what is meant by work. Now look into these pictures here. Here we see in the first picture that boy is applying a force and he is pulling a toy towards him. Now in the second picture we see that this boy is applying a force on a chair and he is pushing the chair away from him. Now in the third case we see that boy is applying force on a wall, but this wall does not move from its position. Now look into each of these cases. Can you think in which of these cases work is said to be done? So here in the first two cases we say that work is done, but in the last case we say work is not done. Why is it so? Let's see that now. When a force is applied on an object and if the object moves in the direction of the applied force, then we say that work is said to be done. So here in both the cases, you see that force is applied on the object. Here force is applied on this toy car and this toy car moves in the direction where he applies the force, which means he is pulling it towards himself. So the object moves towards himself. Now in the second case we see that force is applied by this boy on this chair, which means he is pushing the chair away from him. So the object moves in the direction of the applied force. But in the third case we see that force is applied by this boy on the object. Here the object is wall. So even though he applies a force on the object, that is wall, but wall does not move. That is, the object does not move in the third case. So work is said to be done only when a force is applied on an object and when the object moves in the direction of the applied force, we say that work is done. So here we understand that in the first two cases, force is applied on these objects and the objects move in the direction of the applied force. But in the third case we see work is not done because the boy is applying a force on the wall and wall or the object does not move. So in the third case work is not done. Now let's have a look at some of the examples of work done. As you see here in these pictures, walking, running, swimming, playing games like cricket, football, badminton, carrying a load up a staircase, pushing or pulling a trolley, all these are some of the examples of work done. Now let us see some of the examples of work not being done. As you see here in the picture, work is not done while standing or holding something and standing, pushing or pulling an object that does not move. These are some of the cases where work is not done. So now we have learned about work. That is, a force is applied on an object and if the object moves in the direction of force applied, we say that work is done. Now let us see what is meant by energy. Let's take an example. When we ride a bicycle for a long distance, we all know that we get tired, isn't it? Yes, and we will be unable to ride it any longer. Now, why do you think this happens? This is because we use up our energy to ride the bicycle, that is, to do a work. Therefore, we see that energy is needed or it is required to do the work. So, what is meant by this energy? The ability or a capacity to do work is known as energy. All the living things that are there on earth requires energy to do work. Now we need energy to perform different activities in our day-to-day life like playing, swimming, climbing a staircase, reading, and even while we sleep, we require energy. But where do we get this energy from? We get energy from the food that we eat. The foods that are rich in carbohydrates and fats are called energy-giving foods. Some of the examples of energy-giving foods are cereals, wheat, rice and maize, potatoes, sugar, fruits, oil, ghee, cheese, cream, butter, milk, etc. So these are some of the foods that gives us energy, which means these are foods that are rich in carbohydrates and fats. Food items that are rich in fats will give us more energy compared to food items that are rich in carbohydrates. The energy we need actually depends upon the work that we are doing. For example, look into this picture here. We know that we need more energy to run compared to the energy that is required to walk, isn't it? Yes, same like that. We need more energy to play outdoor games like cricket or football compared to the energy that is required to do work sitting at home. Similarly, we know that we need more energy to climb stairs compared to the energy required to use an elevator. So the energy that we need will depend upon the work that we are doing. Now let's have a look at different forms of energy.